Welcome to this week's MTD Podcast, the power of artificial intelligence and how it could completely revolutionise manufacturing. This is the subject today. I'm Giovanni Albanese, hosting today's show, a passionate engineer and a proud member of the MTD team. I'm joined today by two very special guests. Firstly, we have the pleasure to be joined by Chris Edwards from ESPRIT CAM UK. Chris started his CAD-CAM career back in 1985 at Aston University, I believe. Since then, he's worked for some of the largest and successful CAD-CAM companies, and now, recently in 2018, started a new venture with DP Technology, setting up a UK subsidiary for ESPRIT CAM UK. Welcome, Chris.
Thank you, Gio. It's really a great pleasure to be on your programme today.
It's a pleasure to have you, Chris. Really looking forward to figure out a little bit more about this artificial intelligence. Can't wait. Really exciting topic. And we've also got the pleasure to be joined by our very own Mark Deadman, with over 30 years experience in the machine tool and UK manufacturing sectors, launching magazines in areas such as aerospace, and in the last 6 years has been a dedicated director at MTDCNC. Welcome, Mark. We've certainly got a lot of experience on the podcast today.
Yeah, I think so. And there was a lot of D's in there, to be fair to you, Gio. So, but no, it's very good for Chris to be joining us. And, CAD-CAM's, certainly revolutionised machine tool. So I'm looking forward to learning a little bit more.
Chris, let's just start. Yeah, I've only just touched upon your kind of engineering career and background. Can you give us a very brief overview about yourself, how you got into engineering, some of the projects that you've worked on, and how it's led to where you are now?
Okay, yes, certainly, Gio. I mean, really, if I wanted to start at the very beginning in terms of engineering, I'd probably go back a little bit further than 1985 and say that I started out as a civil and structural engineer from the University of Sheffield. And then I spent some time after graduating working in London. And I was this is related to CAD-CAM in a strange sort of way. I started working at a company called Stress Concrete Design, and we were using the first computer models for designing bridge decks. And so it was working in that sort of sphere that got me interested in CAD and CAM and design and finite element analysis and things like that. And so after a period of time working at both Stress Concrete Design, Costains, and doing some night work at Gatwick Airport, and I wasn't baggage handling, I was actually building a rapid exit taxiway. I moved on to do an MSc in CAD-CAM at Aston University, which is kind of where you came in. And interestingly enough, it's the same point at which the likes of DP Technology were just starting out with their software. And there was another company called CAM. And really that was my first introduction at the university. I saw a demonstration of the duct product, and I was absolutely amazed by it. It was the first time I'd seen something like that, 3D design. Making a product that could then be machined. It was incredible. And so after that, having seen it, I decided that was the future for me. And of course, it was very much a frontier industry at the time. We were breaking new ground, and exciting times. Yeah.
That's fantastic, Chris. I think that you're also breaking new grounds now with ESPRIT, which we'll come to shortly. Mark, you were heavily involved with all sectors, but predominantly the aerospace sector, I believe. What kind of changes have you seen over the years when it comes to CAD-CAM?
Well, I'll take it back a little bit more, Gio, actually, because when I first started in publishing back in the early 90s, I remember I was working for a publishing company called Finlay Publications at the time, and design magazines, they had a circulation of over 30,000 design engineers in the UK. So if you looked how many design functions there are in the UK, I would imagine it doesn't actually break five figures anymore. And I think that's where software in general has helped the design process.
Yeah, I couldn't agree with you more there, Mark. That's a really valid point. What do you think about that, Chris?
Well, yes, I mean, really, we've gone from very, very elementary sort of modeling techniques in terms of software to now. I mean, we didn't even have email as such back in the day, not at any great level. And now when you see that everything is done pretty much on a mobile phone and communication, and even some design solutions are available on mobile phones, it is remarkable what's been achieved in that 35-year span.
Yeah. It's certainly revolutionised the way in which we can make components, I believe, especially with the complexity of the machine tools and components changing. Now, let's start from the very beginning, Chris. In a few words, what is CAD-CAM for our audience?
Okay, well, breaking it down into its two component parts, it's computer-aided design and computer-aided manufacturing. And here at ESPRIT, we concentrate on the CAM side, the computer-aided manufacturing, rather than the design side. So very much we like to be at the production end of the process, taking other people's designs and making them into reality. So yes, we work with the likes of SolidWorks, for example. We can work with Solid Edge. We can take data from any source and we can read the features, and understanding the features of that component, we can then put it to a machine tool. And in our case, we put it to a machine tool, a simulation of a machine tool, and then that can generate the tool paths. And I think that's very much what we were talking about, or what you were talking about to my colleague Luca Ruggiero the other day when you were discussing AI with him. It's basically the ability for us to very quickly take a model and turn it into a real finished component.
Yeah, no, I mean, I used to program directly into the machine tool, Chris, back in the day. And now, due to the fact, well, a few reasons really, due to some of the complexity of the parts, 3D parts, it's absolutely impossible really to be able to program them into the machine tool directly. Now, Mark, what do you think about some of this new technology?
Yeah, it's a bit of a learning curve, isn't it? Because reflect when you go into a lot of smaller job shops. You see the guys and you're having a chat with them, and you're there for one of our customers that say, Gio, how do you program your machines? Oh, we program each machine. Right. Do you not use CAD-CAM software then? No, we don't. And I think, well, why don't you? It could revolutionise and save you so much time and cost by actually having these programs ready to run, rather than, spending X amount of time, at the actual machine.
Yeah, absolutely, Mark. I mean, we always mention keep that spindle turning, and programming is, if you're doing it on the machine tool, which a lot of people still do, is downtime on your machine tool. Now, Chris, you've got something to say on this. What do you think?
Well, what I was going to say is that, yes, I mean, it's the difference between online and offline programming. And if you want to get the maximum efficiency out of your investment in machine tools, you definitely need to be doing that programming work away from the machine and keep the machine turning and actually producing, rather than having someone banging in coordinates at the actual control. And I think those are the big time savings and production savings that can be made by going from hand programming or manual programming to using any CAD-CAM system. One of the other things that I found back in the 90s was that at one point, the automotive companies and people like that were only sending out 3D models. So companies had to invest in CAD in order to be able to read the model.
Yeah, that's an interesting point. Now, Chris, we recently done a live podcast on MTD, and it was regarding, are people utilising their machine tools and using them efficiently, and CAD-CAM was one of the biggest topics within that podcast. Now, effectively, we've established that CAD-CAM or CAM is a way of programming your machine tool, but now you've revolutionised that, Chris. Back in 2019 at EMO, you launched ESPRIT powered by AI, artificial intelligence. How is this going to revolutionise how we manufacture components, in your opinion?
Well, there's 2 points really. There's obviously what we're currently doing, and there's what's to come. So what we're currently doing is we've got the ability now to actually have a program, a CAM program, if you like, that is independent of the machine tool. So it doesn't have to be a program that's developed for a particular machine tool. It can be developed for a particular series of machine tools, or it could be in terms of, it could be for mill turns or turn mills. And we can actually move the product from one to the other by using our machine swap functionality, which is part of the AI engine. And I think that's probably one of the most significant, developments that we've come up with, because it means that we can start a project on a machine that's just producing single one-offs. We can then go to mass production, and we can be using the same program. And that program, when it's put to the new machine tool, will take all of the setup and the information and all of that it requires from that new machine and produce an optimized tool path for that machine tool. And I think that, for me, is probably the most exciting thing, because it means that really you can move a job around a shop now and not have to reprogram it.
Chris, I'm going to come back to this in a little bit more detail, but effectively what you're saying is you can program your component regardless of the machine tool, write the program in the most efficient way, and you kind of can put it onto any machine tool regardless of the make. And there's something that I want to come into later in regards to the factory developed post processor as well. But firstly, Mark, what do you think of this?
Well, Gio, I was going to ask Chris a question actually, because how do these guys actually come up with a new part to their software? Is it based on customer feedback, Chris, or is it more from a point of view of actually saying, hey, we built a platform here, here's an idea, let's go with it? How does it work, Chris?
I have a feeling that, knowing the two guys, and again, I'm only giving you my opinion on this, Mark, but knowing the two guys that run the organization, Dan and Paul, they very much keep up to date with developments, not just in the CAD-CAM market, but also with developments generally in business and etc. So they know, if you like, where the trending things are, and also what is likely to be a useful addition to what's going on in the CAM market. And they're very keen. The nice thing about our organization is that we have a development group that spans the world. We have people in Tomsk, we have people in Grenoble, we have people in California developing the software. We've got people all over the world, in Berlin as well, doing our development work on the simulation. And because of that, I think they've just generally, they take the best ideas, see if they're going to be applicable to our market, and then try them. And I think Luca touched on it in his interview with you, Gio, when he said, basically, what we look for are the things that are trouble. What are the pains? What are the things that our customers currently have difficulty with? And one of the big issues for our customers is always, well, the spindle's just gone down on machine A, and now we have to use machine B. And how are we going to move that program and set it on the new machine? And is it going to take us a few days to develop a new program that's optimized for machine B? Yeah. So this is where the, understanding that pain, that's where the development comes from.
That takes me on to what I was asking Chris, really. I mean, this is totally revolutionary innovation, in my opinion. That's one of the functions that you call machine swap, I believe. Now, effectively, you're doing all your programming virtually. You can cherry pick machines from the cloud. It will know all of the machine tools' capabilities, and obviously you're working closely with the OEMs to achieve that kind of information. But AI is taking it to a completely different level, and surely it will require different mindsets as well, Chris. Now, moving it to a machine, can you explain how you don't really need to convert G-code anymore?
Okay, the essential thing the point to make on that, Gio, is that yes, we do produce G-code at the end. So each time we put the program on a new machine, or we do a machine swap, we still output G code to the machine tool. That still exists. But what we're saying is that G code, we have a traffic light system on the software, so that when we're looking at that series of processes, as long as it's got a green light and it's ready to go, we know that G code is going to be right for the machine, because it's already been verified with the manufacturer. We've already checked the DMP against their specifications. We know the limits of the axes and everything. If we're going to have to unwind the head, we know which direction we're going to have to unwind the head, etc., etc. So all of that is there, so that we can be producing collision-free toolpaths, basically. Now, the traffic light system is green, amber, and red. If there's an amber, then what it's saying is it's flagging up. Just take a look at those links, and it might be that you've got two simultaneous processes, and it might be perfectly safe. It's just that because there's two operations happening at the same time, just take a look and be careful. And if it's a red, it's a no-go. So by having that simple traffic light system, we're able to communicate to the operator of the software, you need to do some more work on your toolpath before you submit it for post-processing, if you like. But once you post-process it, it's ready to run on the machine.
Now, optimized production is obviously something that everyone's looking to do, Chris. How does artificial intelligence optimize production?
Okay, Gio, the way in which that works is that we, for example, and the example that you've seen before, and we're using quite extensively at the moment, is going from a single part setup on, say, a Mazak, moving that over to a DMG, horizontal machine of some sort, and the single part, and then we're moving to a tombstone with 12 stations. So in that case, when we do that, the software itself knows that for the single part, it's just got to enter, do the machining operation, and exit. For the tombstone, what it wants to do is it wants to finish off all the parts that it can with a single tool, and it will do that in sequence. So it'll load a single tool from the turret, into the turret, and then it'll do all the machining operations that are required for that tool before picking up the next tool in sequence. So if you like, it's making that decision as to whether it's going to do each part individually or whether it can group them together in some way to get the minimum path, so that we're saving time. We're not returning back to the tool station every time, picking up a new tool, or even just going to a safe height or whatever. We can just carry on continuously finishing with the one tool before we go on to the next, picking up the next tool.
And it rewrites the programs automatically, Chris.
So what it does is there is a button. Basically, you load the new machine tool. There is a button that says Optimize Toolpath, and you click that button, and that's what it does. It optimizes the toolpath. So all the processes that I just talked about, it does that automatically.
Blimey. Now, Chris, we've started to bring machine tools and equipment into the equation. Now, I read some stats, Chris, that turning for high-speed metal removal and in increasing tool life by up to 100%, and reducing cycle times with up to 70% plus savings. Yeah. I mean, these are astonishing figures. But before we move into the savings on machine tools, Mark, you've got a lot of experience in the EDM areas as well. I've never really assumed that there's much need for CAD-CAM wrongly in EDM. Mark, what do you make of it in that arena?
Yeah, well, EDM's been around for quite a long time, and I think personally it's underrated, because there's certain parts you just can't machine on a machine tool. It's impossible. But obviously with sync and also wire machines, there's a possibility that you get a job in, and obviously you need to do something. So that's where EDMs have become very, very popular. And obviously there's a number of manufacturers out there that have their own software, and obviously the guys get trained on it. But I am noticing that once that they've got one EDM in, you see more EDMs coming into these companies, and then they start questioning, well, why don't we actually program these actually offline? That's the sort of experience that I've got, Chris. Are you seeing this as well?
Yes, well, Mark, we actually have, we obviously started out in the EDM market way back when. And yes, the fact of the matter is we put our software with certain particular machines anyway. So, for example, Sodic use our software with those. And a lot of people think that, 2-axis wire is very simple. That's true. It is very simple and easy to program. When you get up to 4-axis and 5-axis wire, it's getting very, very complicated. And I think that's where the advantages of a CAM system such as ESPRIT are, in being able to drive those much more elaborate machines now that are capable of doing much more complicated profiles, and can even program a 5-axis rotary as well. So yes, I think offline is always one of those things that if people don't think about it, you'll never get there. But if you want to consider it and look at it, then there's a whole plethora of software out there that could help improve efficiency.
Mark?
Yeah, that's an interesting answer, Chris. As I say, because I think EDM, programming EDM, understanding EDM, it's a bit of a black art still, isn't it?
Yes, yeah, I think it is. I mean, I think that, as I say, the simple stuff, you can put a profile into an EDM machine, a bit like you can on a controller of a machine tool, and you can generate a 2D path, and you can even do a 2.5D. You can crank the wire over at different angles. But the complexity of the machines now, and some of the stuff that you can do, such as pocket destruction and things like that, that's where the software really comes into its own. So yes, I think there's I've always said CAD-CAM is a tool. You should use it where it's appropriate. If you can do the job just as quickly, in 2 minutes on a machine tool control, then I wouldn't expect people to move from that position. But if you basically spend a large amount of time tying up that expensive piece of machinery, doing the programming work, then it's much better to do it offline. And as I say, there's lots of offline solutions out there. We happen to believe, and I would say this, wouldn't I, that we've got one of the best for wire EDM.
Now, Chris, I mean, it's a big statement, and we've touched on now complexity of machine tools. Now, you mentioned earlier on about looking for problems, looking for pain points. Complexity of machine tools and multi-axis machine tools, 5th-axis simultaneous machine tools, sliding head with multi-axis. We mentioned 500% savings on tool life, 70% cycle time reductions. Surely, when you kind of can achieve these astounding results, the return of investment would be instant, wouldn't it, Chris?
It is quick, yes. I mean, we are typically looking at return on investment for our software in less than 6 months, which I think is remarkable. Sometimes we've had customers achieve that on just one project, So yes, it is remarkable, the savings that can be made. I mean, when you think about it, I always liken the machine tool disposable item is the tooling, and that's the one item that costs the most, really, over the year in terms of investment. You're always using that because it's a consumable product, and if you can lengthen the tool life, then you're going to save a lot of money. All extensions and tool life save you a lot of money.
Yeah, very, very, very good point there, Chris. Now, Chris, let's move on to machine tool builder technology. What is this?
Machine tool builder technology, great. That's basically, we've got the ability to now, we've if you like, we've uncoupled it from our software, so we can actually allow our partners and people who are interested in doing creating their own simulation models. They can now access that technology as a separate module, if you like. So as an example, we have Mazak working with our machine tool builder technology to integrate with their smooth control, so that their simulations on their controllers can be can be realistic and as realistic as the ones that we have within the ESPRIT software. It's exactly the same machine tool builder. And the nice thing about that is it extends further than just the machine tool kinematics. We're also looking at coolant and controlling other aspects of the tooling.
How far away is that, Chris?
It's available now.
Oh, fantastic. Now, yeah. Mark, we discuss automation all the time as well. This is another key area to improve efficiency and to create unmanned running. Mark, how do you think we can incorporate CAD-CAM or CAM with automation, Mark?
Well, as I was going to ask Chris a similar question, actually, Gio. Is that, Chris, I'll throw it to you if it's okay.
Sure.
You know, obviously automation has become a big part of the industry to be cost effective, let's say. How has your software been enhanced, or how have you actually got round the subject and given bigger benefits to your customers?
Okay, well, one of the aspects of our software is that we don't, as I mentioned earlier, we don't actually have our own CAD. So we use other people's CAD, such as SolidWorks or SpaceClaim or something like that. And the ability to then read that model in and capture the features of that model plus the manufacturing information is a very powerful thing to be able to do. And that's something that we can do with our software. So we can capture, if you like, the design intent and the manufacturing information. And we have a module which we call knowledge-based machining, which allows us to build applications which can automate production. So for families of parts and things like that. But not only that, we can, if a pocket, for example, is moved on a part or removed, we can update the tooling, the tool path and everything for that operation. And so so we actually have associativity as well incorporated in that software.
Because I've noticed you've also got a machining cloud. So obviously a lot of this data is actually going into the cloud then generally, is it?
Okay, well, the machining cloud is something that we set up to allow basically anybody, and it doesn't have to be just ESPRIT users. There are other CAM softwares that use the machining cloud. It's a resource for tooling so that you could load very quickly models of the tooling, plus the holders, plus the holding systems, plus chucks and any peripheral items that go into a machining operation to help you with your simulations. So, and also to make an accurate simulation. So, for example, when you see those rotary, we showed a simulation earlier on a DMG. I think it was an EVO or a DMU. And we had a rotary table and we had 3 stations of holders. All of that can be modeled in the machining cloud and then can be readily accessible across a team of CAM engineers that could then access that and then use that as part of their simulation within the workshop so that they get an accurate representation of the actual tool holding that they've got and the work holding as well.
Chris, it sounds to me like you're really taking things to different levels. And I mentioned earlier on in this podcast, especially with artificial intelligence, a subject that some people are not too familiar with. Is education the key? Is this required? You know, we mentioned a change of mindset, looking at things differently, looking out of the box. Is this the key for you, Chris?
Well, you've touched on a subject very close to my heart, actually, Gio, because for me, training the next generation of engineers is probably the most important thing that any of us could be doing. I mean, as you can see from my profile, I've been around a long time and I'd like to be around a lot longer. But also we need to bring on the next generation of engineers and we need to make the technology that we're using today available to them in schools and colleges, so that they can be trained up quickly on it. They can get an understanding of what the benefits are, so that when they go out into the world of work, they can also be good ambassadors for CAD-CAM and for manufacturing generally. And I've always said that it's not just about the CAM software. It's about the tooling. It's about the machine tools. It's about understanding the whole combination.
Yeah. And Mark?
Yeah, a great example. A few years ago, I was with a customer. A new machine's gone in, and the control was, as we would class it, like a sort of an iPad. The first guys on it programming it were the young apprentices. The skilled guys who programmed in a different way did not have a clue, I assure you.
Yes, I think that's the other thing. I mean, I've seen applications in the CAM market available on iPads and on mobile phones, and I'm sure that's a trend that will continue. And also, as the number of buttons you have to press in order to get a program out diminishes, again, you'll be able to use more portable devices to do that.
I think it's certainly an absolutely fantastic industry to get into. I think that it's undersold, really, to the younger generation. I don't think they realise what a fantastic industry it is. It's certainly at the forefront of all technologies. It's been brilliant to have you on the podcast, Chris. We're just about to wrap up, really, but there's just a few other points I'd like to make before we do so. You've obviously joined the MTD platform, which is fantastic. So we'll be covering some of the products that you offer in more detail through video and testimonials, technical corners, so on and so forth, Chris. But for potential listeners that have listened to this podcast and may want to try and start dipping their feet into the ESPRIT CAM software, you mentioned to me, Chris, that on some older DMG Mori machines that they've already got a license. Yes.
I mean, it is the case that we call these the NH machines, but DMG Morisiki originally had an agreement with ESPRIT, probably going back about 10 to 15 years, whereby there was a license of ESPRIT, which was called Mori for Maps, put on each machine. And so a lot of machines are out there still with that software license. And we are very prepared and very happy to work with those companies and look at putting the latest version of the software with those machines so that they can access the AI and all of the points that we've been discussing today. So, those machines are out there. They've already got a license of ESPRIT. It would be really good if people are interested for us to get in touch with them and to be able to let them trial the latest versions of the software. It sounds a fantastic initiative, a little bit like we've been working on, Mark, with pushing the stock to try and help industry really get back on its feet during these challenging times. Mark, have you got any final thoughts before we have to, unfortunately, leave? I could talk all day, Mark, but...
Well, Gio, you know me very well. I've always been quite a direct person, and I'm going to put Chris on the spot a little bit here. Chris, tell me what sets ESPRIT apart from your competitors.
Okay, well, there are many things. I think the prime point that I'd want to say, though, is that we have control of all of our own development. And, we were talking about the speed of development that we have. It's because we focus only on the CAM market. And in fact, we only focus on the areas that we've been discussing today. So, wire EDM, 2 to 5 axis machining, all of the sliding head technology, multi-channel and things like that. But that's it. And so we can be very innovative. And also, when we do simulation, we use our own simulation product. When we're doing additive, we're using our own additive product. We're not using a third party. So again, we can bring everything together very quickly in one easy-to-use user interface. And I think that's probably what sets us apart from a large number of our competitors, if not all of them.
Thanks, Chris.
Thanks, Chris. Well, I think that's rounded it up absolutely perfectly. Chris, thank you very much for joining me. Mark, thank you very much for joining me. Thanks for joining the MTD podcast. For all the listeners out there, we hope you've enjoyed this podcast. Please comment and tell us what you think. And if you want to get in touch or find out a little bit more about ESPRIT CAM UK, you can visit the MTD CNC platform website to check out some of the latest videos that we've been producing together. Until next week, the MTD Podcast.
Thanks for listening to the MTD Podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on MTDCNC.com.